So here is another question on arithmetic progression for general nth term. So it is given if m times the mth term of an AP is equal to n times the nth term, show that its m plus nth term is 0. Okay, so again let us say that for the given AP we have the first term that is equal to A and the common difference that is equal to D. Okay, so here the mth term Tm, it will be equal to A plus m minus 1 into D. This is the mth term. Okay, this is the mth term. Okay, let's call it equation 1, and we have the nth term Tn is equal to A plus n minus 1 D. Okay, this is the second term. Now according to the question, m times the mth term is equal to n times the nth term. Okay, this is given in the question. So if we put these values here, okay, if we put these values here, mtm and tn, so we have m into A plus m minus 1 D is equal to n into A plus n minus 1 D. Okay, so we have, that implies MA plus m into m minus 1 D is equal to NA plus n into n minus 1 D. Okay, this much. Now if we subtract, now we bring this to the LHS side, so we have MA plus m into m minus 1 D minus NA plus n to n minus 1 D, that is equal to 0. Okay, so now we have, that implies MA and here minus NA plus m into m minus 1 D minus n into n minus 1 D, that is equal to 0. Okay, MA and here we have opened the bracket minus NA together plus m into m minus 1 D minus n into n minus 1 D, that is equal to 0. Okay, so now here we take A common, m minus n plus D common, m into m minus 1 minus n into n minus 1, that is equal to 0. So we have, that implies A into m minus n plus D to m square minus m minus n square plus n. Okay, this equals to 0. Now that implies a into m minus n plus d into m square minus n square minus m minus n, this equals to 0. We have written in this format. So that implies a into m minus n plus d into m minus n into m plus n, writing m square minus n square as this much, m minus n into m plus n minus m minus n is equal to 0. So that implies a into m minus n plus d into m minus n, taking m minus n common, we have m plus n minus 1. This equals to 0. That implies m minus n, taking m minus n common, we have a plus d into m plus n minus 1. That equals to 0. Now here see, what is the formula for the general nth term? Let's say T capital N. Okay, that is equal to a plus n minus 1 into d, where this is for the nth term of the AP. Here we have a plus, combining this, m plus n minus 1, m plus n minus 1 into d is equal to 0. So we can call this whole thing a plus m plus n minus 1 into d equals to 0. We can call this portion as the m plus nth term. This expression a plus d into m plus n minus 1, this much. This portion is the m plus nth term, or we can write it as m minus n t subscript mn, which is the m plus nth term, sorry, mn not, it's m plus n, m plus n, that is equal to 0, because this is t m plus n, this one, a plus m plus n minus 1 into d, this is the m plus nth term. So that implies t m plus n is equal to 0 by m minus n, which is equal to 0. So basically the m plus nth term, that is equal to 0. So we have proved it, that the m plus nth term, that is equal to 0. Okay, so same thing, first we written the expression for the mth term, then we wrote the expression for the nth term, small m small n, then we equated both sides, then we subtracted and rearranged the terms, taking small a, that is the first term, and the common difference common. Then using some basic algebraic identities, we rearranged the whole equation in such a format that we got the m plus nth term, and we proved that the m plus nth term, that is equal to 0. Okay, so this is the